It's time for Astronomy Daily Live. It is 2:02 UTC. I am like over 120 seconds late. That's just huge. That's just huge. So yeah, that's beginning to look like a bad habit. So I need to step up the game a little bit here and you know um, get myself on at 2 hours UTC, because that's when this live stream goes live every single day, with some rare exception. So I think, Bobby, you've been a panelist what for maybe a week and a half now or something. I'm not really
Something
paying
like
any
that.
attention, but yeah. So Bobby is back on the panel. So how's everything going over there?
All is well here.
Cool. Very cool. So I'm seeing Hip is in the chat. Nice to see you. It's been a little while. So thanks for coming in again. We definitely have some hip hype there. Uncle Bill, nice to see you. Tom, hey. Hope everything's well. There's just hype everywhere, including in this container here. A lot of hype in here. Huge amounts. On the porch panel. Yes. It's the porch panel. That's great. Absolutely great. That's, I mean, as I say, what I sort of have in my mind, right, is that we're all out on the back porch, right? And it's sort of a covered porch, but it's starting to get dark, but you can hear all the insects and you can see the darkening clear sky, and it's calm and it's cool. Yeah, just extremely awesome. Oh, I don't know why this is doing that. Oh, I know why. Ooh, I might be really close to killing my oh no, it killed itself. Look at that. Poor thing. So yeah, for some reason I'm still not exactly sure why, but if I try to to uh, to YouTube anything live through my Linux machine, the whole machine, uh, after a certain amount of time, right? It's sort of like it builds up and builds up and builds up and just gets slower and slower and slower and slower until the whole thing just absolutely stops.
And how old is your Linux machine?
The physical machine itself is actually pretty old. I want to say it's probably maybe 8 years old or so. So, but yeah, it's always done this, and yeah, I'm not exactly sure why. And I mean, really, if I cared a lot, I would probably do something about it. But I don't care enough. So yeah, I just wonder. So nice to see Daniel back in the chat as well. Do I have? Oh, I see what happened. Okay, let me kill that chat, and I'm gonna pop out this chat. Okay, and then I'm gonna do that. So yeah, I sort of see this as a nice porch, and we're sitting back in our lounge chairs with our you know drinks and or other consumables in hand, and yeah, this is definitely I haven't really been tapping into the dihydrogen monoxide uh, much lately. Um, I've been trying to keep it really calm and cool with this hydrogen hydroxide. So cheers. I'll grab my chat again. I, you know, earlier I was looking at my, and I don't really pay much attention to views or any kind of stats or anything, but um, I noticed that the Astronomy Daily Live for the 21st of July has gotten 41 views, which is like twice as many as what I normally get. And that kind of information, like who is viewing, I don't think I have access to that kind of information. I think that's too personal, right? So I don't know who, I mean, I suppose it could be, one person, just reloading and reloading and reloading. Um, so maybe that's what happened. But yeah, I just kind of find it's sort of a strange anomaly that yeah, I got twice as many views on that particular stream, and I don't know why. So yeah, I guess it's one of the mysteries that I'm just going to have to deal with. So I I mentioned these books from time to time, and I think it's time that I mention them again. These are um, two books that I really enjoy um, for different reasons, of course, but I highly recommend Asimov's I, Robot. Have you read these, Bobby?
Um, what's the difference between the movie and the book?
Totally different. I I I haven't seen the movie, so I mean I can't be absolutely sure. But what this is um, this is a series of short stories, right? There's what, 9 of them there. So 9 short stories, and what this does, this is a complete introduction to Asimov's robot world. These short stories explain the history and some of the early problems that they had. He came up with these 3 laws of robotics, right? And what he does in these stories and in the other robot books that he has put out is um, you know some kind of problem caused by those 3 laws that has to be solved, right? So um, a lot of his well, at least the first 3 robot books, which is the Caves of Steel. Um, yeah, so the Caves of Steel, the Naked Sun, and there's another one. Am I gonna see it here? No, I'm not gonna see it. Um, Dawn, something Dawn. Can anybody help me out in the chat? I forget exactly what that third one is. Anyway, those books are, I mean, you could characterize them as mystery novels because that's sort of what they are. They're solving a mystery, um, and these are sort of the same way. So anyway, if you ever get a hold of either the audio or the actual book, highly recommended. Highly, you will if you like sci-fi, um, you will definitely like like that. And yeah, um, Bobby, as far as I know, the movie I, Robot maybe took some ideas from Asimov, but I don't think that it, followed any of the stories or anything like that. I think that, that's right, the Robots of Dawn. Thank you, Tom. Yeah, uh, yeah, and Uncle Bill, sitting there in the chat, he says that the movie has almost nothing to do with the book, um, except using positronic brains and very, very loosely the three laws of robotics. So yeah, there are certain movies that I will not uh, go see because it usually based on a book, right? So Lord of the Rings, uh, never seen any of the movies. I never will, right? Because I've read the books and I've got certain um, images in my head of what all the characters look like and how they behave, based on my reading of the book. Uh, and so, yeah, and iRobot was one of those that I was like, well, I'm not going to take a chance. I'm not going to go see this one, just in case, you know, it is some kind of thing based on either um, all the stories or one of them.
It,
And
it's
yeah,
kind of like a bit crazy when they take ideas out of a book that they leave out of context and stuff. They leave all the parts of it.
what I what I don't like really is somebody else trying trying to put pictures into my head of things, um, especially if I already have some kind of idea about what I think, as I said, they look like or anything like that. So yeah, there are certain movies I just won't see, and could probably be all right with iRobot now, but it actually doesn't look all that interesting. So Uncle B is from the future. Well, I think that Uncle Bill um, is in many times, many at this, simultaneously, right? He's in the future. He's in the past. He's here right now. I think so. I think so. I think that's part of the ninja thing, is that he's got a handle on not only space but also time as as well. So I'm extremely grateful that not only is he, you know, supporting this live stream, he's helping, and I think it's very wise to sort of be on his side. So I'm going to be nice to him because yeah, I think he's got a hand uh, in a lot of space and time. So yeah, Uncle Bill, you're great. So the other book that it's it's really interesting. In fact, I was reading another one of and I don't remember I don't remember where. Oh, here it is. I can recommend two of Bucky's books, Buckminster Fuller. Now this one, like a few of my books, does not have a front cover anymore. Um, Sorry about that, but this one uh, is called. Let's see if I can get it right here. Utopia or Oblivion. Utopia here. It's not going to focus really, really well. Utopia or Oblivion.
I can see it pretty darn well.
Okay, good. Good, good, good. And now this is a really hard read, right? I mean, look at the font size there. I mean, it's tiny, right? Tiny font. I would say that's like 8-point font or so, and you know, there's no pictures. There's no pictures, and I'm like, what kind of a book is this without pictures? I don't know. But anyway, it's a lot of words, and it's. Oh, wait a minute! I thought I saw. Oh no, that was a. I'll bet you there's got to be some pictures in here. Bucky couldn't possibly get through a whole book without pictures, could he? Yeah, I guess he is. That's pretty good. These are a lot of his lectures that he gave, public lectures, and all that. So I'm just looking at the table of contents here. And yeah, so pretty interesting read. So Utopia and Oblivion. So that sort of goes along with, I guess, what we were recently talking about, post scarcity. So sort of along the same lines. And then another one of Bucky's books that I highly recommend is Bucky's 9 Chains to the Moon. Now, he wrote this in 1938, and it's I mean, it speaks to right now really, really well. It's really amazing. Buckminster Fuller was a person way, way, way ahead of his time. I think maybe a little bit frustrating to himself, right? Because he's got all these great ideas, and he's just way early on a lot of things. So, but thank the geodesic dome. Okay, thank him for that. And actually thank him. Nobody ever talks about this, right? But Buckminster Fuller was the first person to organize and name Earth Day. So I mean, that was his doing, and I think his first Earth Day was like, I think 1970. And very, very, very soon after that, the environmentalists sort of took it away and changed it to sort of the Earth's Environment Day. But Bucky had this concept about this spaceship we're on, and let's try to understand how it operates, because if we understood how it operates, maybe we could live on it better, right? Take advantage of how things happen already, and use that to our advantage, and just improve things that way. Very, very awesome. Daniel, thanks for coming in. Got called into work early. Boo hoo hoo. That's how it goes. But thanks for coming in. It's Yeah, is it is it like 22 afternoon there? Not sure. And let's see, yeah. Yep, the work hype call. Yeah, um, Uncle Bill Asimov's nonfiction uh, is pretty good stuff. I haven't really read a lot of it, um, but the little bit that I have read, um, yeah, has been really, really good. As far as I know, he focused on scientific topics, right? I mean, he didn't. I I don't think he jumped off of science, right? Can't be sure about that. So anyway, there's just a couple of book recommendations for you. Um, I've got uh, I've got some pretty interesting books. So yeah, I should show a few more off there. You know, of course, not all of them are astronomical. They're sort of all over the place. Got any good books, Bobby?
I'm not a book reader.
How about a book listener?
Yeah, it could be that.
Hmm. Yeah, yeah. I used to read a lot more, you know, sci-fi and novels um, years ago, but yeah, now most of my reading is journal papers and news articles and that's about it. Once in a while, I'll sit down and read. You know, I mean, if I have to go and wait somewhere, I'll definitely bring a good book. I'll bring some Bradbury or Asimov, and um, it's I never get to read long enough though. You know, it's always like, oh man, has it already been an hour? Arr. When I was working at the University of Arizona, used to take the bus in and out, and that was really really great because I didn't have to bother with traffic at all, right? And I guess the price you pay for that is that you have to walk to a bus stop and you have to wait, and then you got to get on the bus, and then I think it was like a 45-minute ride one way. So I would be on the bus like an hour and a half every day, and it's like I'm going to read, right? And so that is when I did sort of the majority of my reading was was then, because I had an hour and a half a day. What is that? Let's see. There it is. Always always within arm's reach. So an hour and a half a day times 5 days a week, say. So that's 7.5 hours a week. And well, assume 50, 50 weeks a year. I never took vacations or anything, but there's holidays and whatnot. So 50 weeks a year, that's 375 hours of reading a year. So that's not too bad. It's an hour a day. Not not bad. Not bad. Um, let's see. I'm just catching up on the chat here. Okay, yeah, yeah. Uncle Bill is just talking about Asimov a little bit more. He was often guilty of careless math. Yeah. Well, that can get you into trouble for sure. For sure. It's you know, uh, if you're going through trying to solve a problem, right, and you're doing some kind of derivation or something, um, one little mistake anywhere along that is definitely going to change your outcome. So yeah, that's pretty funny. Pretty cool. All right, let's see. Cheers. So Mars is at opposition in, I want to say like 2 or 3 days. It's 2:28 UTC on the 25th of July, and I think the opposition to Mars happens on the 27th. So let's go over to cloudy nights and look at the calendar. And because the calendar was the time, I'm going to start up my smartphone, which I should have done. The planet that wasn't. Huh, okay. I don't think, I definitely have not heard Uncle Bill. I'll have to try to check that out. Well, there we go. So let's go over to cloudy nights. Cloudy nights. If you haven't signed up for cloudy nights yet, get on that, because this is a site very active. It's everything astronomy, um, amateur astronomy. So this doesn't really touch any aspects, getting into what the professionals do, but it comes as close as you possibly can. Um, some of these folks in here are pretty serious and having a blast. Mars it is Mars is at 5 hours UTC. 5 hours UTC on the 27th. Now, that's an interesting time because I'm in southeastern Arizona, and so that puts me 7 hours behind UTC, which would make it 10 p.m. here. Now, I think it might be a little bit interesting. Now, I don't know what the sky situation is going to be like, right, on or at 5 hours UTC on the 27th. But I'm going to say for the record that if it's clear, I probably will do a live stream where we are looking at Mars through the telescope at 5 hours UTC. I think I can do that. I think that'd be very cool. That's in 2 days. Today's the 25th, right? So we got today, tomorrow, and it would be the next day. So I think I'm going to plan on that. Probably still do a regular live stream that day at 2 hours UTC, and then do a little pause, and then probably start up a live stream maybe around 4:30 UTC, something like that. Maybe go for an hour or so, just looking at Mars, right? I mean, that's all that's going to be around. Jupiter might be set. Saturn's going to be over there too. So, we can look at Mars and Saturn and maybe something else. Who knows? trying to think. Let's see. Mars is over um, in Capricornus, right? So yeah, maybe there's some interesting things over there that we might be able to see. I don't know. I don't know. We'd definitely be able to see like some binary stars or something like that. But I think spending some time looking at Mars and looking at Saturn on the 27th, I think that sounds like a plan. It's pretty late for most people, but being where I am, that's not too bad. So yeah, I think I'm gonna plan on that. It's a little bit late, but that's okay. That's all right. I mean, we can we can have a discussion with Mars and try to negotiate a maybe a more convenient opposition next time. So we'll have to get on that and see if Mars can be a little bit more accommodating, because 5 hours UTC is a little inconvenient. So, and there's a lunar eclipse um, coming up for those in Europe. I think it's coming up. I don't know. Does Cloudy Night say anything about that? Uh, yeah, that is also happening on the 27th. It's happening on the 27th. It's happening about 12 hours after Mars opposition. So that's pretty cool. That's pretty cool. So anybody in Europe, right? That's happening um, late in the day, right? 1714 is what the calendar is saying here, and I know that you're not seeing the calendar, but I'm just sort of reading it here. Okay, so it begins its penumbral phase at 1714. The actual midpoint. Well,
Cosmic.
yeah.
I'm gonna be right back and stuff. If you're still gonna be on, I gotta go to the store.
All right. Well, cool, Bobby. Thanks for coming in, and yeah, if this is it, have a great night. Otherwise, pop back in. Yeah, we'll probably be here for at least another half an hour or so, at least. So cool. Cheers. All right. Well, cool. So let's go back to sharing this, because I'm looking at things you should also be looking at. So it says that the eclipse begins at 1714:38, right? And full moon takes place at 2020, and the instant of greatest eclipse occurs at 2021:45. So that's actually a little bit late for you folks in Europe too. I mean, that's 8 o'clock at night. I think is the sun still up? I think the sun might even still be up. For those of you in northern Europe, at least. And Mars is very, very bright. It's probably one of the brightest I've ever seen it. Yeah. They're saying here it's magnitude negative 2.8. And yeah, that's just insanely bright and big, right? 24.3 arc seconds. That's big. So yeah, let's as I said, let's plan on uh, me doing a live stream at starting at 4:30 UTC on the 27th, and probably going to about 5:30 or so. And we'll look at 5 hours UTC. We will be looking at Mars, right? Or at least looking at an image of Mars. Um, yeah, the Puritan in me is like, yeah, you really should be eyeballing it, right? Getting those actual photons right there. But we can skip that kind of excitement. Broke stellarium, huh? Wow, that's terrible. Terrible, terrible. Well, you'll get it fixed, Uncle Bill. No problem. No problem. All right, well, cool. Let's I don't think that we've really done much of an object of the day. Let's do that. There were a bunch of new papers about the Mauna Kea spectroscopic explorer that came out just today. So if you have an ongoing interest in that project, they're putting a new telescope up, brand new. It's going to be dedicated to spectroscopy, which is absolutely fantastic. Spectroscopy will allow us to um, find out things about the objects that we're looking at. Stars or galaxies, whatever they are, clusters, um, spectroscopically. So we'll be able to tell things like their temperatures and their ages and their masses and their composition. Um, you know, how much of what stuff uh, is in there. I was looking at a paper that I think came out today that was talking about seeing copper atoms uh, inside the spectra of stars, and they're trying to speculate on how could that copper get there. And the story is that uh, due to a supernova, all this material gets highly compressed, squeezed, right, like really really tightly, such that you know you're actually changing the atomic structure of matter itself, right? Um, Converting it to from um, whatever it is, right? Hydrogen, helium, carbon, oxygen, neon. Um, you know, Sort of the results of earlier phases of nucleosynthesis, right? Where the we're talking about various stages of fusion. Um, but in order to get the heavier elements to first be produced and then be spread around, you need a lot of compression and then an explosion. So they came up with this idea of a supernova, which it does indeed seem to do uh, what we think it's doing. As to why, I don't know yet. I don't know if we know those answers yet. So yeah, it was kind of interesting. They found neutral and singly ionized copper in these. I think they were red dwarf stars. Can't be sure about that. Um, some kind of dwarf star, not a white dwarf though. Some cooler um, stars, and of course, we've observed copper in the spectrum of our sun as well. Did you know that there was superheated H2O? Yeah, I think it's like 4,500 degrees. But they're seeing molecular H2O at that temperature on the sun. There's gold. There's I think pretty much every element, every naturally occurring element, I think has been found in the spectrum of the sun. Is that can anybody confirm or deny that in the chat? So yeah, definitely. I think if it's clear, I will be out looking at Mars at opposition. So at 5 hours UTC on the 27th, you betcha. I want to be looking at Mars, and I'll share that with all of you for sure. All right, let's do an object of the day, and let's see if we can do sort of a deep dive. So I'm going to share my screen again. We're just going to do an NGC object. I'll choose one from the NGC catalog, the new general catalog. And before we do that, let's nail this this little piece of trivia. So I want to say that the new general catalog came out in the 60s or the 70s. Let's find out. New general catalog. Let's see if we can find out when this thing was first created. So the NGC contains 7,840 objects. It's one of the largest comprehensive catalogs. Includes all kinds or all types of deep space objects. Oh wow. Okay. Well, I am off by 100 years. Wow. Okay. So the new general catalog was compiled in 1888. Okay. All right. I I I had no idea that it was that old. Absolutely no idea whatsoever. Wow. Yeah. No, 130 years old. It's 130 years old. Now, Bill Tift created the R NGC catalog, which is just an update, right? That's all it is. Okay, well now we know. 1888. Wow, that's a nice surprise. See, as a scientist, I relish in being wrong, because when you're wrong, you learn things. So yeah, let's go to random.org and let's pick one of these NGC objects. 7,840 of them. All right, you ready? Here we go. 7097. Now it's probably a galaxy. It's probably a galaxy. So don't get too excited. All just waiting with bated breath. And you're going to turn blue here in a minute. So I better hurry. Let me make sure. 7097? Yes. 7097. Okay, here we go. Probably a galaxy. Yep, it's a galaxy. Looks like it's an elliptical galaxy, E5. E5, so E stands for elliptical, and then 5, I think that has to do with compactness. As I said, let's do a little bit of a deep dive here and just get to the bottom of some things. Elliptical. It's really been a bad typing day, so you gotta forgive me. Galaxy types. Looks like there's a diagram here too. Okay, so it's the amount of ellipticity. If we can see that picture again. I don't see it here. Evolution, star formation. See if we can. I like that. I like that picture, but I don't see it here. Google Galaxy facts and definition. Let's see what that says. That, I don't know if I'd call that an elliptical galaxy, but okay. I guess I'm just going to let's just click on that. Okay. So, yeah, just, sort of interpolating here, the number references the amount of ellipticity. So the more elliptical the galaxy is, the larger this number will be. So E5. I'm not quite sure what that D is. Can't be sure about that one. So pretty big, right? Pretty big, 1.3 arc minutes along the major axis, just sort of like that, and 0.9 arc minutes across, and a position angle of 25 degrees. So I guess, yeah, I mean, if this is 90, then 25 would be off that way. I guess that's how I'd read that. And these are different filters that are used. These are actually called the Johnson filters. They're missing one there, and that's U, which is even bluer than B, which is blue. But yeah, BVR, JH and K. JH and K are moving into the infrared. So I think J is, I want to say like 1.5 microns, 15,000 angstroms. H, I think, is like 2 or 1.7 microns. And I think K is like 2.2 microns, 22,000 angstroms. Oh, we can look at that too. Look at that too. Curiosity, it's a staple. Johnson filters. Probably be here. photometric letters. Okay, so, right, so U, which isn't on this list, is at 365 nanometers with a 66 nanometer bandwidth. So to convert that to angstroms, if you're more used to angstroms, just add a 0 onto the end here. So B is at 4450 angstroms with a 940 nanometer or angstrom bandwidth. So there's B, and that corresponds to this B. So we're measuring the brightness of this object as that light goes through a filter. So only this light is actually coming through, right? Centered on that wavelength with that band pass. So, you know, what is that? 494 divided by 445. So, about 1/5 of the wavelength is the band pass. So that's a pretty wide band. You're letting a lot of light through. So V, it's called V visible. That's at 5510 angstroms. So you can see it's a little bit brighter in V, right? In astronomy, the magnitude scale is backwards. So the larger the number, the fainter the object. So this magnitude 11.71 is brighter than a magnitude 12.66. So that just means there's more light there. And then R, let's see, where's R? So that's at 6580 angstroms is R. And then there's a bunch of others. This is the entire Johnson set. Let's see, they did J, H, and K, is that right? Yeah. So J is at 12,200 angstroms. H is at 16,300 angstroms, and K is at 21,900 angstroms. So yeah, I think that was close there. I think I said 1.2, 1.6, and 2.2. So yeah, it was actually pretty close. Memory serves well there. And this is definitely what I would call a southern hemisphere object. Look at the declination there, negative 42. It's 42 degrees below the celestial equator. So yeah, that's definitely a southern object. Right ascension of 21 hours, 40 minutes. So that puts it way outside of the galactic plane, of our galactic plane. And that you can see here, these are the galactic coordinates. So it's yep, pretty far out of the galactic plane, which is one of the reasons, at least, why we can see it so well. It's because we don't have anything obscuring it. So 7097. Let's see, other interesting designations. Yeah, not really. Just a bunch of different names for the same object. A bunch of references. That's nice. Let's see, distances and velocities. See how far away this thing is. Looks like it's relatively far. So that's what, if we average that, I don't know, maybe around 34 million parsecs. So a parsec is 3.26 million light years. And we multiply that by 34. So it's 110, almost 111 million light years away. So that's, that's still relatively close to us. It's not, I mean, it's not a rock's throw, but that's sort of in our vicinity still. Pretty close, pretty close. It looks like it's moving away from us. It's a little bit of disagreement there. What, 2602, 2457. So roughly, what, 2,500 kilometers per second or so. So that, of course, is a relative motion. We and it are moving away from one another, at least according to how one interprets redshift and all of that. So not too bad. Let's take a look. It says that it's a galaxy in a pair of galaxies, so I'm sort of expecting to be able to see a few more galaxies around. Not really seeing what they're talking about in terms of a pair of galaxies. Looks like a single galaxy. There's one here. There's something here. But, zoom out a little bit more. Yeah. Not really seeing what Sinbad is calling a pair of galaxies. I hear a Bobby. Oh, I don't think there's anything there.
Hey, I'm back.
Hey there, Bobby. Nice to hear you back.
Yeah, so what are we looking at?
Well, we're just looking at empty space right now. I thought, we'd just sort of do that. It's kind of fun. It's pretty interesting. You can use your imagination. No. We're looking at NGC 7097, if I remember right.
All right.
So it's an elliptical galaxy, pretty elliptical. They're calling it an E5, right? So the number there sort of describes the amount of ellipticity. So around one, and I think there actually is a round one down here. I'm thinking that that's a galaxy, but that would be, more like an E0 or an E1, right? If that's an E5, and I think there's another elliptical up here. Yeah. And I might call that an E5 or an E6 as well. But, it's really amazing to think about the idea that we're looking at, hundreds of millions, hundreds of billions of stars right there.
And what is NGC 7097 again?
It's an elliptical galaxy.
Okay.
This dude right there. Right there. So I'm thinking I want to try to figure out what constellation this guy is in. So since Uncle Bill's stellarium is down, I'm going to go to the good old backup, if I can find it. Where did I put it? There it is. Okay, I'll be right back in just 2 seconds. Well, maybe 10. All right, that was a little bit more than 10. But let's see. I'm going to stop sharing the screen because I'll show you how I look it up on a chart. So it's at 2140 and negative 42. 2140 and negative 42. So I use this, which, if you're into paper and charts and all of that, this is absolutely awesome. Otherwise, get a copy of Stellarium. It's fantastic. So we're doing negative 40 something, right? Yeah. And we want 21 hours. See if I can find it here. Oh, next chart. Next chart will do it. Oh, next one. Bad about that. Maybe even the next one. Okay, so let's look and see. So 2140 and negative 42. Oh, I got to go one more chart. There we go. Kind of hard to hold. 2140. 7097? Yes. So it's in the constellation of Grus. Grus. And it's actually associated with quite a few galaxies. I'm going to try to show you where it is. Okay, so I'm going to put this down and I'll show you the chart. Hold on. Let's see if I can. So yeah, so I know that you couldn't see that incredibly well, but yeah, it's in the constellation of Grus. There's a whole bunch of galaxies around it. Definitely, probably part of some kind of a cluster, I would say. So let's just take a look and see what's been studied about this bad boy. Looks like quite a few references. Nothing recent, right? 2016, maybe it's the last time. They're looking for dark matter. Okay. Doing spectroscopy. Galaxy groups. Let's see, how much dark matter is there inside early type galaxies? Oh, and an early type galaxy would be most of the elliptical galaxies, because those are thought to be very, very old and therefore early galaxies. So that's why they call those early type galaxies, as I recall. Let's see, optical imaging for Spitzer. A BL Lacerda object is a particular kind of galaxy, sort of a active nucleus that's actually shooting out a beam. So I don't know if this object is one of those or not. Let's find out. Let's find out. Probably not, but we'll go over to ADS, which is awesome most of the time. Most of the time. Here we go. Come on. Oh, I'm not sharing my screen yet, am I? Let me do that. Bad on me. Share that screen. There we go. Let's just do a search on 7097. Oh, cool. Here we go. So the most plausible object responsible for this absorption, whatever absorption they're talking about, is the halo of the early type NGC 7097 at 100,000 parsecs. So they're saying 100,000 parsecs. Oh, from the target. Okay. So see figure 4. Okay, so I guess this is an object associated with 7097. Let's see if we can find, what was it? Figure 4? We can find figure 4. It's figure 4. It's figure 1. Let's look at figure 4 here. Ooh, here we go. Ooh, there we go. We even got a picture of it. Okay, so this is the PL Lacerda object, and this is NGC 7097, our object of the day. The left field shows the galaxy possibly associated with the calcium-2 absorption system. Huh. We'd have to read, the paper in order to really get an idea. But, huh. For some reason, this object is associated with that galaxy. Was this? Now, I guess we'd have to dive into the paper, which I am not. I don't think I'm going to do. Okay, those are the only three mentions. But okay, what are these guys doing? Let's just see if we can tell from the abstract. Okay, so they're just measuring the redshift of these objects. And of course, when you take a spectrum, you find all kinds of things. Very cool. Very cool. All right, what else here? What else we got? Let's see. So I don't quite know why 7097 would be mentioned. Something like that. 4649 is going to be in a completely different part of the sky. Don't know. Oh, wow. Here's a whole paper on it. Okay, so this is, well, let's just, I mean, how can we skip over a paper which has the object of the day in its in its title. We just can't do that. So let's go back over to ADS. Come on, Slowpoke. Yeah, you lie. There you go.
Do you actually believe that when it's night out there, everything stops unless there's an emergency?
Everything stops what?
When the sun goes down, do you believe that everything stops unless there's an emergency?
I I don't think that very much stops. Yeah, I don't think so. Don't think so. No, no, no. See, that's just bad news. Look at that.
Yeah.
Thank you, Bubba. Appreciate it.
Oh, no problem.
The service which does the job is currently overloaded. You got to be kidding me. Oh, that is not fair. That is not fair at all. Sorry, we're unable to produce the PDF at this time. Well, that's not very nice. That's our object of the day. We can't have that. Let's see. Is there another source? Let's see. That's just unacceptable. So let's see. Three-dimensional spectroscopy techniques are becoming more and more popular. So this was published in 2011. Producing an increasing number of large data cubes. The challenge of extracting information from these cubes required the development of new techniques for data processing and analysis. We apply the recently developed technique of principal component analysis, tomography, to a data cube from the center of the elliptical galaxy, NGC 7097. Very cool. Associated with distinct physical characteristics. And a weak broad component. Furthermore, we extract spectrum. Very cool. Let's just take a quick look here. So they are calling this thing having an active galactic nucleus. That's cool. E5. So they're calling it an E5. 32.4 million parsecs away. So that's about as far as we calculated. Strong emission of the singly ionized oxygen and singly ionized nitrogen. Pretty cool. Let's see what else. So they looked at they used Gemini South here. I think Gemini, oh man, I want to say that Gemini is a 4-meter telescope. Don't quote me on that, but I think it is. And yeah, they just use a spectrometer. So they can observe the object and the sky simultaneously. That's pretty cool. Most of the time, with spectra, you have to look at the spectrum of the object itself, right? By looking at the object, and then you have to move away. You have to slew the telescope over a little bit and just catch some sky. But apparently this can do it simultaneously. That's cool. But what I'm looking for is some images and some spectra. And there we go. Cool. Okay, I'm not quite sure what we're looking at here unless this is an actual image. I guess it is. I mean, it's showing it in arc seconds. This is definitely a spectrum, though. It's pretty cool. Here they've identified a few species, right? Singly ionized silicon, singly ionized nitrogen, neutral oxygen. That's pretty cool. Oh, come on now. Sodium, oxygen, and here's hydrogen beta. H beta, my favorite color. So yeah, pretty interesting. I'd have to read this in order to really understand what they're doing. But somehow they're taking this information and turning it into a spectrum. So interesting. Not quite sure what's going on with that. Say 2 to 5. Yeah, we'd really have to get into this to understand what they're doing, but yeah, I guess it's interesting to see some pictures, though. But yeah, this is flying over my head a bit. All right, good to look up. Pretty short paper. Let's see, they usually have conclusions. Okay, so yeah, they're just introducing this new way of looking at the spectra of objects, and they use this galaxy just as an example.
And Uncle B picks his stellarium.
Yay! Very, very cool. All right, well, I think that it's about time to exit these waters. So thanks, everybody, for coming in again. If you're new to this, make sure to subscribe. Hit the thumbs up if you haven't already. Definitely make some comments if you like. I like to hear, all kinds of things. Criticisms, for sure. One of the things in this live stream that I'm trying to do every single day is get better and better and better. And that's that can be a relatively slow process. But I figure I've got 10,000.
About what Uncle Bill said. Yeah, they're trying to push HTTPS down. They've been very strict on that.
Oh, okay. Well, I don't think that's that terrible of a thing, right? I mean, it's a little bit of overhead, and websites have to have a certificate and all of that. But it's like, if it's encoded, that's probably better. Probably. So, all right, I'm going to get out of here for now. So take care, everybody. I will see you in a little less than 23 hours from now. Yeah, I think that'll do it for tonight. Yeah. I'm getting the signal. Getting the signal for sure. So, all right. I will see you all tomorrow on the spin. Take care. All righty. Bye.
Hey,